Okay, let's have a look at what is called a sigma bond. So, in fact, we've been working with sigma bonds. We just haven't been calling them by that name because a sigma bond is actually what we know as a single bond. A single covalent bond like we have in a CH bond. And so what we can use as an example is our methane molecule. That's a good place to start, CH4. And let's draw the geometry of it. We know that it is tetrahedral, like so. And we have our 4 hydrogens placed like this at 109.5 angles. Now what I'm going to draw on top with this green highlighter, and hopefully it'll show up, are the hybrid orbitals. And so before I do that, let's just label that this carbon, you know that this carbon is in an sp3 hybridized state, okay, because it's got 4 electron groups around it. It needs a hybrid orbital for each group, for each single bond pair of electrons, and so it is using 1s and 3 p's. And if I look at the electron configuration of carbon from the periodic table, I can see that its valence electrons, we'll just grab the periodic table here to remind us. Okay, here's carbon. And right there, and carbon we see is in the second row, and if I slide it over this way, it's the 2s2 is filled, and I have 2p2. 2s2, 2p2, which means that, I'll write it down here, my s2s in particular, and then I have 1, 2, 3, my 2p orbitals. I'm not going to draw them in, but I have 2 electrons here, and then 1, 2 electrons there, so it's a 2s2, 2p4. But more importantly, for the purpose of this discussion, the valence electron orbitals, atomic orbitals, are the s and the p, the 2s and the 2p. And when carbon hybridizes to accommodate the 4 hydrogen atoms to which it's bonded, it needs all 4, so it will hybridize all of these. Remember when we did this in class? And it needs 4, so it's going to take an s and 3 p's, and it will then create 1, 2, 3, 4 hybrid orbitals, each called sp3. And so each of these sp3 orbitals now are a lobe. It's not a beautiful figure 8 like a 2p orbital, but rather it's mostly p with a very tiny bit of s in the back. So when we draw it superimposed here, I'll just draw a lobe from the central carbon pointing in each of these directions. And these are a bit smaller because I'm trying to get that 3-dimensional look, successfully or not. So here's an sp3, and this is an sp3, and that's an sp3, and this is an sp3. Got it? Okay, so those are the 4 orbitals. Now I'm going to draw the hydrogens in a blue marker. So hydrogen is not hybridized. It only has, you know, a 1s orbital, but I need to make these overlap, so I'm going to draw the circle like that. And so you see where it's overlapping? That's where I have a sigma bond. So hydrogen just has its 1s. And the place of overlap is the sigma bond. And so I'll just shade in the overlap. And that's really where the bond is. Okay? So if I want to describe what a sigma bond is, then I write it in the following way. Let me just write it down here underneath. Okay? So each of these CH bonds is a sigma bond, which is always a direct Okay, direct overlap. And we say a direct overlap because these are pointing towards each other. Well, this is a sphere, so it can't help it, but this hybrid orbital is a lobe pointing in the direction of the hydrogen. So it's a direct overlap between. So anytime you write out a description of these covalent bonds, you're going to write that it's a direct overlap between, okay, if it's a sigma, it's a direct overlap between an atomic orbital on one of the atoms and, or with, an atomic orbital on the other atom. Okay? Because that's what these bonds are. They are overlaps of atomic orbitals. And so now I'll just fill it in for this specific case. So I am describing the sigma bond between the carbon and the hydrogen. And I'm not describing any one in particular because they're all identical. So I only have to write one description and that covers it all. So each sigma bond in methane is a direct, and I can't tell you how important it is to write this word because sigma goes with direct, okay? That's very important. It's a direct overlap between. So let's label what it is on carbon first. So hybrid orbitals make sigma bonds. So it is direct overlap between an sp3 hybrid orbital on my carbon and there's only one choice here. It has to be the 1s on the hydrogen. So anytime you write out, as I said, the description of a sigma bond, what is in pen is really your template, and you'll just be considered filling in the blanks. I didn't mean to mark that there. So in methane, each sigma bond is a direct overlap between an sp3 hybrid orbital on carbon and the 1s atomic orbital on hydrogen. Okay? Great.